Hey guys, welcome to Pre-Calculus on Wednesday. This is going to be the last topic for the week. It is the application of vectors, and I think you've probably learned over time that application just means word problems. So when you think of applications, just think we're going to be doing some word problems. So I've got this. Oh, by the way, you're going to need your calculator. And you're going to want to make sure that it's set in degree mode. So get your calculator handy, ready to go, so we can do some word problems. So I'll put this on the blog so that you guys can print this out. I am not a fan of the parallelogram method at all. So you will see me sticking to what's called the component form method. Right here. Okay, this is the component form. So we'll be using basic calculation of sine and addition, and then we'll be doing some distance formula right here, and a little inverse tangent down here. Okay. So a lot of the problems are going to be asking for you guys to give them the magnitude and amplitude, or otherwise known as the direction of the vector, or the resultant vector. Okay. So these are the two things that we're going to be, these are mainly the answers. Most of the word problems that we're going to do, these are your answers. This is the process in which we're going to get the A value and the B value so that we can come down here and put it in the distance formula and put it into inverse tangent so that we can answer the final question. So just to kind of set up this component form, u cosine theta, u sine theta, what this is going to be the first vector that's given to you. Okay. And then the second one, the v cosine, v sine, that's the second vector. Okay, we're going to add those two together. So what we need, oh, and by the way, it's going to ask you this too. This is known as the horizontal component, and this is the vertical component. Think of it as a big ordered pair, okay, where the x value comes first and the y value comes second. So this is the horizontal component. This is the vertical component. Again, this is the component form. So they're going to give us maybe just one vector. Most of the problems give us two vectors. If they give you one vector, then you just have to take the magnitude of that vector and multiply it by the cosine and then multiply it by the sine. It's pretty simple. Okay? And then it's possible that they give us two, and at that point we get to use the distance formula in the direction. Okay, or in the inverse tangent. So away we go. First problem, down here in the bottom, it says construction. Let me get rid of this other paper. Scoot that up a little bit. Okay. So Roland's pulling a crate, construction materials, force of 60 newtons. That right there, that's the magnitude at an angle of 42 degrees. And so that's your theta right there with the horizontal. Find the magnitude of the horizontal and vertical components. Okay. So we want the magnitude. So that means we're going to be doing the distance formula. So we have to figure out the A value and the B value, which is the horizontal and the vertical. And then we will use the distance formula to figure out what that is. Okay? So we're going to use this formula up here, which is the magnitude of the vector, okay, which is the u. That's going to be the 60. And let's not use blue. 60 cosine the angle measure, that would be theta, so that's our 42 degrees, comma, because we're going to have another calculation, we're going to do the sine calculation, so 60 sine of 40 degrees, so 42 degrees. This is where your calculator comes in. So we're going to make sure that the calculator is set up in degree mode. I'm in degrees. Good to go. So we'll do 60 cosine of 42. That's 44.6. We'll go ahead and round that to one decimal place. 44.6. And then we'll do 60 sine of 42. This is going to be the vertical component. 40.1. Okay, so this is the horizontal and vertical component of the vector. So we want to find the magnitude. So we'll do the distance formula between these 2 points. So that's 44.6 squared plus 40.1 squared. That's 40, not a 46. So you can do that all at once in these fancy calculators. You can see it. Let's put that up a little bit more. 44.6 squared plus 40.1 squared. Hit enter, and you get 59.96. 59.97. Which basically is the same force, because that was the magnitude up here. So we even went through the calculations and proved that the magnitude was going to be 60. Okay, so this is an atypical word problem. Okay, this is not the typical problem, but it does use the component form. Okay, and if we had done inverse tangent, guess what angle we would have come up with? We would come up with 42 degrees. Okay, so excuse me. This is our process. So we're going to use the component form. We're going to do some addition. Find out what the horizontal and vertical components are. Plug them in the distance formula. That's one answer. And then we'll plug it into inverse tangent, and that'll give us our second answer. Okay? Let's look at a real word problem. Actually, let's look at a real word problem. Okay? That's pretty similar to the one that we just did. All right. With time running out in the game, Rodney runs with a football at a speed of 3.8 meters per second and throws the ball 7 meters per second at an angle of 28 to the horizontal. What is the resultant speed and direction of the ball? So when they say speed, that is the magnitude, and this is the amplitude, otherwise known as the direction. So we're looking for two things here. So let me kind of draw you a picture. Show you what's going on. So Rodney, okay, Rodney is running with the football this way. And so Rodney is running at 3.8 meters per second, okay? And he is at 0 degrees because he's running along the field, okay? So he's at 0 degrees. He launches the football, okay, at 7 meters per second at an angle of 28 degrees. So we have two vectors. We have the vector that Rodney is running, and we have the vector that the football is traveling. So somewhere in the middle here is a vector of the football. Okay? So because he's running at 3.8, and so the ball is moving at 3.8 and then gets launched at 7 meters per second. So it's going to be somewhere in the middle of all that. Okay, so we've got a third vector that we're talking about, and this is what this formula is going to create. Okay. All right, so let's do the calculating. First vector is going to be Rodney. Rodney's at 3.8 cosine 0 degrees, 3.8 sine 0 degrees. That's the blue vector. The green vector is the football itself, okay, after it's been launched. So we've got 7 cosine 28, 7 sine 28. And we're going to add these together. Now when we add these together, we're going to be adding these two together. Oh, I need another color. And these two together, because this is the y component, that's the vertical component, and this is the x component, okay? So you can't add x and y together, but you can add x and x together. Calculating time. Okay, now you can do this whole calculation right here at one time, but you got to make sure you use parentheses. So 3.8 cosine of 0, close your parentheses, plus 7 cosine 28. I'll go ahead and close that also. And this component is 9.98, which we'll go ahead and call 10. All right, on to the y part. 3.8 sine of 0. Make sure you, ooh, what happened there? Sine of 0. Close your parentheses. Didn't get the 0 in. Plus 7 sine of 28. Boom. So that is 3.3. So 3.28. We're just going to round everything to one decimal place. All right, so these are the components of the new vector. So this is the horizontal component. This is the vertical component. So it's basically making its own triangle going 10 out and 3 up. All right, so magnitude of it. The speed of the ball. So we do the magnitude by using the distance formula with these two values. So our speed is 10 squared plus 3.3 squared. Clear all that out. Square root 10 squared plus 3.3 squared. It'll do it for me at 10.5. So this ball is moving 10.5 meters per second. Okay, so that's the speed. We'll scoot this up a little bit. And we'll find the angle at which the ball is traveling now. The direction. So this right here is answer number 1. 10.5 meters per second. Now let's find the direction. What angle is the ball traveling at? We know the speed that it's traveling at. Now what's the angle that it's traveling at? So to find the direction, you'll see that its tangent theta equals b over a. So that's the y value over the x value, just like all tangents are. Now to get the theta by itself, you have to use inverse of tangent. So that's why I'm telling you over here that we're going to use the inverse tangent. So if we know we're going to use inverse tangent, we can go ahead and set it up as tangent -1. And then the 3.3 value, which is the y value, over the x value, which is 10. And this is why we want to be in degree mode. Okay, because we are calculating a sine, cosine, or tangent, and we are in degrees, so we want to make sure we're in degree mode. So inverse tangent, 3.3 divided by 10, enter, and that ball that Rodney threw is traveling at 18.3, I'm sorry, that's the degrees. That's the degree at which the ball is traveling. So it started out with Rodney just running at 0 degrees, and then he launched it at 28 degrees, so that means that the angle that the ball is actually traveling in the end is somewhere in the middle of those, and so it ends up being at 18.3 degrees. So that's a typical word problem. Using the component form, find the components, the horizontal and the vertical component, use those values in the distance formula to find the magnitude, and in inverse tangent to find the direction. Okay? So I got one more for you. Okay? So we have two vectors. We got a boat, travels at 30 miles per hour, due west. That's an angle. So that angle, think about which direction due west is 180 degrees. If there's a 7 miles per hour current at 120 degrees, find the actual speed and direction of the boat. Okay, so I'm going to draw the picture over here. So we have a boat that's traveling due west. So we have this boat that's hanging out. It's going this way. There's the boat. 30 miles per hour, and it's going at 180 degrees. We know that because it's going due west. And there's a current. There's a push, okay? 7 miles an hour push at 120 degrees. 120 degrees is going to be up here. So this is 7 miles per hour at 120 degrees. Which basically means that the boat is actually traveling in this direction right here. Somewhere in between the 180 and the 120. Somewhere in between them. Our job is to figure out exactly what speed and what direction the boat is traveling. Okay, so we'll use our components. We'll start with this blue vector. We are 30 cosine 180. 30 sine 180. The angle is going to be the same. The magnitude is going to be the same. What's different is the cosine sine parts. Then we have the current. The current is 7 miles per hour. Cosine the angle, 120. The current is 7. Sine 120. And we get to calculate that. So we'll concentrate our calculation on this. We'll add these two together. Then we'll come in and we'll add these two together. This is all in the calculator. Clear that out. 30 cosine 180 plus 7 cosine 120. Get the decimal of that. Let's see. Negative 33.5. Okay, then we'll move over. We'll concentrate on the y value. Now, I want you guys to think about these numbers. Negative 33.5. That's an x value. That means it's going left, just like we are. We're in the second quadrant. Okay, so if we're going to be up, this value right here is going to be what? Positive or negative? Think about that as we calculate it. All right, so 30 sine 180 plus 7 sine 120 gives me positive 6.1. So now these, as the horizontal, let's see what we got. The horizontal and the vertical components of this orange vector are doing exactly what it's supposed to do. Negative, which is going left, and then positive, which is going up. And that gets us to this orange vector right here. So that's good. That's good stuff right there. All right, let's find the actual speed. So this is the distance formula of these two numbers. Negative 33.5 squared plus 6.1 squared. And it should be in between these two, okay, because the current of 120 is messing with the speed of the boat. So square root 33.5 squared plus 6.1 squared gives us 34. Now, why is it just 34? Because that's a reference angle, okay? So we have to use 34 degrees from the horizontal, going in that direction. It's a reference angle. So this takes you back to the basics of trigonometry. So 180 subtract the 34 degrees is 146 degrees. 146. Oh, that is... Oh, nope, sorry. I was calculating direction. So whatever we got from that was correct. So 34 miles per hour. I jumped the gun and moved on to direction. Sorry about that. Got a little ahead of myself. There's your miles per hour. Forgot what I was doing. All right, move on to direction. What is the direction? This is where we have our angle measure, and we may have to calculate a reference angle in there, okay? So we can just ignore that. That's not right. All right, so direction is the inverse tangent of 6.1, the y value, over the x value, which is negative 33.5. All right, let's see what this gives us. If it's not in between 120 and 180, we're going to have to calculate, or what they're giving us is a reference angle, and we have to add or subtract to get it into the second quadrant. So inverse tangent, 6.1 divided by negative 33.5. Boom. Negative 10. Okay, so what that's doing is it's telling me it's negative 10 from 180 degrees. Is it 10.3? 10.3. So we have to add 180 degrees to get it into its second quadrant. So it's 10.3 degrees from the horizontal 180. So plus 180 gets us 169.7 degrees. Oops. 169.7 degrees. Okay, so that's two typical problems. Two typical problems where they give you two vectors. Got to calculate the speed, calculate the direction. Two vectors, calculate the speed, calculate the direction. Okay, so we'll have 7 of these types of problems on your homework tonight. Okay, 7 problems. There's a worksheet. The answers will be posted to the blog. The work won't be there, but the answers will be there. On Wednesday, you'll have a quiz on adding and subtracting and applications. The adding and subtracting are going to be in Delta Math, where the applications will be on the blog. I post on the blog, so you'll have to submit those to me. All right, so good luck. You guys ask questions where you need to. See you soon.